Hey everybody, my name is Zach. I work as a cybersecurity analyst, and I created a set of videos that I hope will be helpful for anybody wanting to learn about PowerShell. So at this point in time, the cybersecurity job market is pretty rough, but I feel like having a solid understanding of certain tools will help you. So I created some videos regarding PowerShell. We talk about commands in PowerShell. We talk about things like creating scripts in PowerShell, so on and so forth. It's very interesting. And like I said, if you're trying to get in cybersecurity or you're already in cybersecurity, you just want to have a better understanding of what PowerShell is and the possibilities that lie inside of that tool. I feel like this training will be great for you. So without further ado, let's get into it. First off, PowerShell is a command line shell and scripting language developed by Microsoft. So it's a command line shell and scripting language. So basically, you have the command prompt, which you can perform command line type of activity, ipconfig, so on and so forth. And then you have PowerShell, which is the command line plus scripting. And we're going to talk about scripting in a second, but just wrap in your mind that PowerShell has components of the command line, and then it also allows for scripting. You cannot do scripting in command line. So PowerShell is that. It provides that functionality, right? So it's a scripting language developed by Microsoft, and it is widely used by system administrators, cybersecurity professionals, and hackers. So PowerShell allows IT professionals to automate tasks, manage systems, and execute powerful commands. So we talk about automation, management of systems, so on and so forth. PowerShell allows for this capability. So let's quickly look and see what are some of the use cases. So we're going to take a system administrator. Everybody should have an idea of what a system administrator is. They are administering systems. So let's say we have an organization like Amazon. Amazon has thousands of systems, servers, Windows computers, Mac computers, and the system administrator is essentially the one in charge of making sure those systems are properly configured, deployed correctly, have all of the stuff. So PowerShell can allow for creating and managing users. So we can create and manage users from PowerShell. We can have a script that creates and manages users. Another use case is to deploy and configure software remotely. So let's say there is a specific configuration that we need to deploy across 10,000 systems. We could create a PowerShell script that deploys that configuration to all of those systems with the click of a button. And also we can have PowerShell do things like schedule and automate backup. So let's say we have a Windows server that needs to be backed up every 12 hours. We can create a PowerShell script that performs that automated backup, right? And there are thousands of other use cases for what system administrators would want to do with PowerShell, but it's very powerful. If a system administrator did not have PowerShell, they would be very limited in what they can do. Let's look at cybersecurity professionals. So a cybersecurity professional would be a security analyst, security engineer, a penetration tester, so on and so forth. So one of the things PowerShell allows them to do is to pull Windows event logs. So Windows has their own event logs that get created once enabled. So if you go into Windows event log, there are logs that get created for certain types of activity. So let's say a new process is created on a system. A Windows event log will get triggered, and that event log gets stored on the system. So with PowerShell, you are able to pull those Windows event logs for analysis. So let's say I'm a SOC analyst for an organization and I'm analyzing a system. What I can do is I can pull those Windows event logs, analyze and see what was the intrusion. What time was the intrusion? What time did the intrusion occur? so on and so forth. Also, cybersecurity professionals can use PowerShell for hunting for active threats using process data. So they can form various types of threat hunts via PowerShell. And then we also have collecting a memory or disk artifacts. So this is where we start to get into things like forensics. PowerShell basically sits on top of the Windows operating system. So you're going to be able to pull memory or disk artifacts via PowerShell. So you can write a PowerShell script to extract memory regarding this date and time so that I can perform my analysis of, this artifact that I'm trying to get a better understanding of. So these are just some of the use cases for PowerShell from a cybersecurity perspective. And there are hundreds of more use cases, but for the most part, these are just some basic examples, right? And then, of course, anything that a system administrator uses, or anything, like I said in the beginning of this training, anything that is built for good or built with good intention can be circumvented and used for malicious intention. So an attacker, let's look at an attacker, they can download and execute malicious software. So just like we can deploy and configure legitimate software, an attacker can download and execute malicious software with PowerShell. You can write a script to disable Defender. So Microsoft Defender can be disabled via PowerShell, or any security tool can be disabled. One common tactic and technique of hackers and APT groups is to disable security tools so that the security tool cannot perform its functionality. And via PowerShell, remember, PowerShell sits on top of the Microsoft operating system, so it can disable tools with just a click of a button. Just run a script and it can disable that tool. And it also, the third use case from an attacker's perspective is going to be enumerate systems, users, and shares. So enumeration simply means identifying and discovering. So enumeration is a very important concept to understand. So let's say from a practical perspective, I am a bank robber, and I want to go into a bank and I want to steal money. If I just show up to the bank with a gun and expect to have a successful robbery, I'm sadly mistaken. What's going to happen is I need to go to that bank maybe a day before, act like I'm an actual bank customer. I'm going to scope around the area. I'm going to look to see who exactly is there. How many security guards do they have? How many cameras do they have? Do they have glass doors behind the bank tellers? So on and so forth. I'm going to enumerate the environment. I'm going to try to see and really understand what I can do, and if there's potential for me to successfully complete this attack. So just like from that perspective, attackers can use PowerShell to enumerate systems. So we can enumerate systems, see what services are running, what kind of privileges the users have, what shares they have access to. Enumerating shares is going to be important when attackers want to move from one system to the next. For example, you have an organization where, let's say, the HR department, they all use the same, let's say, PDF for onboarding. Let's say that share is mapped to all of those HR employees' computers. And if an attacker gets hold of that share, he's going to be able to move from one system to the next, and they can expand their attack. So PowerShell allows for the enumeration of systems, users, and shares. And of course, with PowerShell, you can do a lot more. From an attacker's perspective, you can do a lot more. But just to keep things simple, these are just some practical use cases of PowerShell from a system administrator, cybersecurity professional, and a attacker. So in the next part of this video, we're going to be looking at some various commands. For example, we're going to learn about the get.net TCP command, which is a pretty essential command that you do want to have an understanding of. We're going to look at the get process command in PowerShell. Also, we're going to look at the get service command in PowerShell. Lastly, we'll look at get scheduled task. Later on in the training, we're going to look at things a bit more complex, like getting the file hash. We're also going to look at collecting data with PowerShell. And of course, because this is PowerShell and we're talking about cybersecurity, we're going to have to talk about encoding and obfuscation with PowerShell. All right, so this is what we're going to be looking at. Enjoy. All right, so we have PowerShell up. Let's go ahead and run the first command, which is get.net TCP connection. Now, before I click enter, I want to quickly talk about why this command could be helpful. So let's say I'm a SOC analyst or a security defender, and I'm analyzing a system that could be potentially compromised. One of the first things I'm going to want to do is see what are the current connections on this system. All right. What are the current connections on the system? So when I run this command, I see local address, local port, remote address, remote port, state, applied setting, and owning process. So what is this telling me? It's telling me the current connections on this system. We have some that are established. So we see there are some current connections that are established. We can see established here. There's 4 established connections. We also see some where we just have ports, but they're just listening. So there's no connection, but it's listening, and it's available for connections. So these are reserved for us, but there's no active connections, right? And we also have bound, which is similar to listening, and we see that they have not been used yet. Then we have send sent, which means the first part of the three-way handshake. The first part of the three-way handshake is to send a send packet. So the send has been sent, right? So these are all of the states of our current connections. So the main one we would be concerned about if we're analyzing to see if a malware is communicating with a command and control server would be established, right? So then when we look at established, we can see that it gives us, we have the remote address, which is the IP address that our computer is communicating with. So we'll see some different IP addresses here. And then we also see the remote port. So we have 443, and then we have a port 1514. And then we have the applied setting. So very simply, applied setting is it just tells us the type of setting for this type of communication. So we have internet. So internet is a type of setting that we can apply or that will be labeled for our connection type. So the system considers the connection to be public, or it's a connection to an external network. So it's going to be stricter. The security settings are going to be more strict. So whenever you see this internet as an applied setting, it's going to be a stricter security settings, right? And we can tell because if we look 443, those are secure connections, right? So last we have the owning process, which is simply just the process associated with the connection, right? So we have the process associated with the connection. So let's take this first process here, this send between this 10.02 and 10.0.0.156. So if I wanted to understand what is a process associated with this connection, I could run a command that's going to tell me the process name. So I could run get process and then ID, and then I would just take that process ID, which is 3676, and it's going to tell me that this process associated with this connection is the WASA agent. It's the WASA agent, process ID 3676. Don't worry too much about the handles and the CPUs and all of this stuff. Just the key thing to know is that this is the WASA agent. So the WASA agent is making outbound communications to an IP address. Not malicious. Obviously, this is part of our lab where we are building a WASA server, but you get the point. Let's say that this was a IP address we weren't familiar with, and then we got the process ID, and it was with a process called install backdoor.exe or malicious.exe. Then that would trigger me to say, what is this process? And then once I do my further analysis, I would find that this process is actually malicious and it got on our system via phishing email or during a drive-by download. Then what would I want to do? I would want to run this command, which is stop process. And I would give it the process ID, which is 3676, to stop the process. I'm not going to run it because I do not want to stop the WASA service at this point in time, but I could run stop process to stop it, and that would kill that connection. So that C2, that command and control between the malware and it communicating with its command and control server, that connection would be killed right then and there. And that's incident response. So we ran some few commands, but just to summarize what we did with getnet TCP connection, we would run this command to get an understanding of all of the connections on our system, right? All right, so very quickly, we're going to look at 3 more: get process, get service, and get scheduled tasks. So first and foremost, the get process is going to be very important just to see what processes are running on a system. So I'm performing analysis on a system. Let's say the system has generated some alerts, and I just want to get an understanding of what is happening on the system. I just want to get a general understanding of what is going on the system. I can run the get process command, all right? And as you can see, there's hundreds of processes on the system. There's hundreds of processes. So going through each one is not going to be it's not going to be efficient, but at least kind of eyeballing everything and seeing if anything sticks out. I see stuff like sysmon. I see stuff like WinLogon. SVC host is huge. It's a very core Windows process. I see the spool service and things like that. But it would be good to go through and just kind of see if anything kind of sticks out. Let's say we saw something like rootkit or updater.exe or whatever. Here, we would want to, kind of take that process ID and kind of see if there is something suspicious going on with that specific process. But at least we're able to see all of the processes running on the system, right? After the get process, we also have get service. Now, very similar, we are seeing the active services on the system. So we have some status, we have the name of the service and the display name of that service. So we see some of the stopped services and we see running services. Now, services are going to be important when we're talking about malwares because services run in the background. So a lot of the times the malware is going to try to create services. It's going to try to, latch onto some services for persistence so that it can run in the background. So let's say there was a service that was part of a malware that is now communicating or connecting to a command and control server. And that service is running in the background. So as a user just interfacing with the operating system, I'm not going to see it. So, it'd be important to come into the services as well. Just look through all of the services and see if anything, kind of sticks out. Obviously, there's more, efficient ways. Maybe we would want to just filter on services that are running, services that are stopped, and things like that. But, we're seeing all of the services on the system, right? So let's say we wanted to filter just on services that are stopped. We could run get service. We could run get service. And we can do pipe where status is equal to stopped. And it's showing us all of the stopped services. And then the same thing, we can also run and see the services that are running. And it is going to show us all of the running services. So it makes the output a lot less for us to see what services. For example, we see things related to the was a service, which is normal. So that's something we should see. We see the VirtualBox service, things like that, user manager, and things of that nature. So one more command that we can run from PowerShell is going to be scheduled task, seeing the scheduled tasks on a system, right? So in order to see those, we can run get scheduled task. Now, getting the scheduled tasks this is a very interesting thing here. So Windows has given, administrators the ability to create certain tasks that can perform some functionalities, right? So hackers, in order to establish persistence or just to stay on a system across reboots or disconnections from the internet, they will create scheduled tasks. So scheduled tasks were created for legitimate purposes. For example, we see the task name Microsoft Edge update task machine, which is running, which would likely do something along the lines of run a Microsoft Edge update. So it's going to communicate with the Edge, wherever those updates are on the internet, and it's going to, be running those updates automatically for us. We have things related to clean up temporary state, so on and so forth. So again, a hacker can take this type of functionality and run a scheduled task that every 30 minutes or every 1 hour communicate with the command and control server and download instructions from that command and control server that, let's say, steals cookie data or steals credentials, so on and so forth. And then it exfiltrates that to the C2 server, right? So we have various scheduled tasks here as well. And we also see, if we scroll up the state, we have running, we have ready, and we have disabled, right? So running obviously means that the scheduled task is running. Running means that the scheduled task is running. Disabled means the task is disabled. So it's not running, it is currently disabled. So an administrator would need to go in and enable the scheduled task, right? And then we have ready, right? The ready scheduled task. So ready just means the task is enabled and it has all the conditions met to run when triggered, but it hasn't started yet. So it's just kind of sitting idle, waiting for its trigger. So maybe at 6 p.m., the scheduled task, that's the trigger point for the scheduled task. Or when the user PC boots up, then it's going to trigger. So ready simply means it's waiting for a trigger, right? So these are all of the various scheduled tasks. And then again, of course, we can filter based on, whether it's disabled, whether it's ready, so on and so forth. And what I would recommend is going through some of the MITRE techniques, tactics, and procedures, and looking at how some attackers in the past have utilized scheduled tasks, services, and processes to perform their malicious activities. There are hundreds of examples of these kinds of activities, but just from a very simple perspective, if I'm a defender, being able to look and see look at all of the scheduled tasks, look at all of the services on a system, look at all of the processes, so on and so forth. It's going to be very helpful when I'm doing my analysis, right? All right, so next command we're going to run is the get file hash command. So there's different ways we can do this, but let's say we want to check for files in our downloads folder, right? So let's go ahead and let's CD into our downloads folder. And if we do a ls, we're going to see some executables. We see the Zoom installer, and we see sysmon64. If you remember, we did install sysmon earlier. So let's say we just wanted to get the file hash for some of these files. We could run get dash file hash and the path. And then since we're already in that directory, we just need to specify, for example, Zoom installer. We can start typing that Zoom installer.exe, started typing Zoom, and then I click tab, and now it's showing the full Zoom installer.exe. So when we run that, we get the SHA-256, which is a hashing algorithm. And once I have gotten that hash, I can now go into an open source intelligence tool like VirusTotal. And let's say I just wanted to check the legitimacy of the installer. I could paste in the hash here, and it is confirming that this is the Zoom's meeting installer. And we can see, if we go into details, this is very important. We want to make sure that it is signed. This is the key here, is always making sure that it is signed and valid. So it has the Zoom Communications Organization Incorporated, and it is perfect. So usually malware is not signed. Sometimes it is, but usually it's not. So let's say there's a malicious file in my downloads folder, once I got the hash and I looked on VirusTotal and I saw that it was malicious, where there was no hash available. I got a no hash found. That's an indication that, hey, I may need to do some more analysis. Maybe I need to get my reverse engineers involved. Right? So this is the get file hash command within VirusTotal, or within PowerShell, excuse me. And again, it can be run to generate the file hash of a specific file. All right, welcome back. We're going to create a PowerShell script that locates a file on our system and then reads that file and then exfiltrates that file to a server. Now, in order to do this, we need to first create a dummy file. So we're going to open up Notepad and we're going to just create some fake dummy data. Now, I asked ChatGPT to give me some fake dummy data, and it gave me some fake credit card data. So we have name of the person, the cardholder, the card number, expiration, the CVV, BLink address, so on and so forth. And we have it for two different people, John Smith and Jane Doe. Right? Pretty basic credit card data. But with this, you can make purchases online and you can, just impersonate whoever these people are. So what we're going to do is we're going to save this as, we're just going to give it a name. We're going to call it important data. Important data 1. That's what I'm going to name it as. You can name it as whatever you want to name it. And then save it to your documents, right? Save it to your documents. Quick pause. I know you might be wondering how we got to Jane Doe and John Doe's credit card information. And quickly, I want to talk about what a keylogger is, or keylogging. So hackers have the ability to install malware on systems. We talked about this already. Malware can get on systems through phishing emails, drive-by downloads, so on and so forth. So let's say in the example we were looking at, John Doe, we see his credit card information. So let's say the malware got onto John Doe's computer via phishing. And that phishing email, the malware type was a keylogger. So that keylogger gets installed on John Doe's system. Now, anytime John Doe enters in his credit card information, guess what? The keylogger has the ability to intercept that. Whatever John Doe is typing in on his computer, the keylogger can intercept that. So in this case, we have the credit card information for John Doe and Jane Doe. This is a new concept for a lot of people, or maybe you've already heard about it, but just wrap your head around the fact that this is a type of malware. There's thousands of types of malware that do different things, but in this case, think of this as a keylogger that basically can intercept whatever you're typing on your computer. I hope that makes sense. All right, so now what we're going to do is we're going to now create a PowerShell script. So when we're creating PowerShell scripts, I did mention that you can create your PowerShell scripts from Notepad. So that's what we're going to do. So what we need to do is we need to create a PowerShell script that can read the contents of a file, collect the contents of that file, and then upload or exfiltrate the contents of that file to a server of our choice. So first thing we're going to do is I'm going to write a comment and explain out what we're going to do. So we have defined variables. So we're going to define some variables. So the first one is a server. So we're going to create a variable called server, right? The variable server, and we're going to set it equal to, and we're going to do HTTP 10, and I'm just going to put the IP address of my was a server. That was a server is going to act as our command and control server. We're just going to make it seem like it's our command and control server for the purposes of this exercise here. So we're going to label it, we're going to give it that IP address, and we're going to give it the port 8000. That's the port that our server is going to be running on. So now we need to create another variable called local file. So you can label it local file or whatever name you want to. It doesn't matter. The important part is the contents within the variable. So we're going to now take the path of the important data. We're going to copy that path. So we're going to come back to File Explorer. We're going to look for that file, that text file, and we're going to copy the path. And then we're going to specify it in our local files variable. So that's the path. So when the script runs, it's going to look for this specific file stored here, right? Okay, so one more variable we need to create. We're going to label this file content. And we're going to set it equal to, and we're going to put in get content. So that just simply means we're going to get the content in this file, right? And we're going to store it in our local file variable. Just follow me. It'll make sense in a second. And we're going to do raw. So we want the raw file, right? So get content local file. So it should be the same here. So we need to get, that's what we're telling it. Get the content from local file. This is local file. Remember, we put important data.txt path in our local file. All right. Hope we're making sense. So now this is the last thing we're going to do. So I'm going to create another comment, upload the file using post. So we're going to do a post request. It's very important that you understand HTTP methods. We have post, we have get, we have put. We're going to use post request. So to do that, we're going to utilize invoke web request. Now in PowerShell, there is the invoke commandlet that basically allows you to invoke web requests and things of that nature. So just know when you see invoke and then you see web request, we are making a request to a server of some type, whether it be a HTTP server, any type of web server. So we're going to do invoke web request, and then we're going to do URI, and then we're going to do and specify our server. And of course, that is $server, which we used here. So it's going to be that HTTP, that server that we're going to be hosting. And then we're going to do method. And the method is going to be post. So remember, there's post request, there's put, there's get. We're going to be posting the file, remember, here to our server. And the post is going to be in the body. And we're going to do file content, right? Very important that you have the correct server for your WASA server. So I would recommend going to your WASA server and doing the IPA to get that server. So what I'm going to do is I'm going to click on save as. I'm going to also save this into my documents. I'm just going to give it the name. The script is just going to be called collected data .ps1. All right, we have to label it as a PS1. That's a PowerShell script. Collected data.ps1. Now, what we need to do now is we need to go into our WASA server and we need to set up our Python server so we can catch the file that we're trying to grab on our Windows host. All right, so we are in our WASA server. Now, what we're going to do first is we're going to make a directory. We're going to run the command mkdir, which stands for make directory. And we're just going to call it exfiltration test. You can name it whatever directory you want, but I'm going to label it exfiltration test. I'm going to click enter, and I'm going to cd into exfiltration test. Now I'm going to run nano, and I need to specify a name for the Python script we're going to run. So I'm just going to label it exfiltrate _ test.py. All right. Now I asked ChatGPT to build me a simple Python server that will receive requests from our Windows host. And it gave me a simple Python server. So let me paste that in. Now, what is it doing? Very simply, we have our import here. And then it's handling incoming HTTP requests. So we have some simple logic within here that's going to read the size of the incoming data. It's going to read the data from the request. So it's going to take that data that we sent it, and then it's going to save that data to a file called exfiltrated.txt. And then it's going to send back a success response. So if the data was received successfully, we're going to get a 200 response. And then at the bottom here, we're going to specify to start the server on port 8080. So that's the port we're going to be specifying our server on. And 0.0.0.0 simply means that we're allowing any IP to send to this Python server. And when we run our script, we're going to get listening on port 8080. It might be a bit confusing, but just follow me and we'll break it down once we have successfully sent files to our server here. So just to keep it simple, this is a Python server that we are running. All right. So we're going to click on Control O to save it, and then Control X to get out of here. Let's go ahead and clear our screen. So now we're going to do Python 3, and then we're going to do the name of that Python script that we just created. So I labeled it exfiltrate test.py. So go ahead and just, type in whatever name you saved your Python script as, and make sure it has a .py extension, because this is a Python script. And we're going to click enter. And then we see here listening on port 8080. So what does that mean? We're waiting for a connection. We're waiting for some type of data to be sent to us on this server. So it's listening. So now it's acting as a server. That's what a server does, right? The server is waiting for somebody to send some type of data or whatever. So let's go back to our Windows host and let's send that credit card data text file that we had to this server here. All right, so back on our Windows host, what we did was, if you remember, on our Python server we just created and ran, it's specified here. So if you look in the server, remember we did server HTTP dot our IP address of our was a server, and we specified the port 8080. So remember, right now our server is just waiting and is listening on port 8080 for any type of HTTP requests. So we're going to be doing a method. We're going to do a post. The method is going to be a post, and we're going to post the file content, which is here, important data 1.txt. So let's go ahead and open up PowerShell so we can run our script. So let's go to PowerShell, run as an administrator. I'm going to cd to documents because that's where the PowerShell script is actually being stored. And then I'm going to do /collected data.ps1. So once I run this, we should see that the HTTP response is a 200. That's very important. The status code is a 200. Very important that you know this. Look at it. The server is a Python server, so it was able to get and post that imported data in our script to that Python server. All right. And that is a 200 OK. Anytime you have an interview question, they ask you, hey, what is a 200 HTTP response code? Always say that's a successful communication, right? 200 is always going to be successful. That means we were able to do it. So now let's go ahead and go back to our was a server. And as you can see here, it is now updated. So from our IP address, which was our Windows IP address, the date, which is today, we see post and we see 200. All right. Let's open up another window here. All right. Let's go ahead and cd into exfiltration test. And if you do a ls, we now see that exfiltrated.txt. That's that file that was on that Windows host. So we can confirm that was a successful exfiltration. So what we can do now, just to confirm that what we expected from that text file is on this system, we can do a cat command, which is essentially going to print out what we have to the screen. So we're going to do a cat and then exfiltrated.text. And as you can see here, we have the same information that was on that Windows host, John Smith, card number 4111, so on and so forth, expiration date. And this is what we call exfiltration. We just exfiltrated data from a Windows host to our Ubuntu server, this is known as exfiltration, which is a MITRE tactic. And we did that through a Python server. We did that through a Python server on this system and a PowerShell script that captured that data on the Windows. All right, this is fun stuff right here. All right, so for this PowerShell script, we are going to encode a command, and encoding is a very important concept in cybersecurity. It's where we take something that is human readable and we convert it into something that is no longer human readable. And this is a way to kind of obfuscate what we're trying to execute on our system. Hackers use this technique. System administrators also use this technique as well. But to keep it simple, we need to first understand what this looks like. All right, so in order to do this, we're going to open up PowerShell. But this time, we've been using PowerShell, but we're going to use PowerShell ICE. I'm going to run as administrator. Now, with PowerShell ICE open, what you're going to see is you're going to see the PowerShell, the normal PowerShell screen. If we run ipconfig, it's going to give us information. It's just like the normal PowerShell. However, if you click on View and you click on Show Script pane, guess what? Boom. You now see an area where we can create our script. Before, we were opening up Notepad and creating our script and saving it, then going into PowerShell and executing it. However, here, we can create our script here in this area and then execute our script here. Pretty cool, right? So again, we said that we're going to create a script that encodes a command for us. So what is encoding? Again, it is making something that is human readable, not human readable. That's the most basic definition I can make it. So let's say I wanted to open up calculator application on my computer. So if I wanted to open up calculator, what would I do? I would just come here, boom, click on calculator. Now, there is another way. If I wanted to open up calculator from PowerShell, I could just run start process. I can use that commandlet and then say calc. And boom, calculator opens up. Let's say I wanted to open up Microsoft Paint. I would just type in MS Paint. And boom, Microsoft Paint comes up. And you can draw something nice. All right. You're getting the idea. Let's say we wanted to open up the registry. We could run start process reg edit. Right? And boom, our registry comes up. So what we're going to do is we're going to create a encoded command that is going to encode what we're going to do. So we're going to do a start process. All right. We're going to do a start process of calc.exe. So we're going to create a variable called $CMD. And then we're going to do start process calc. All right. So that's the first part of our script here. We're going to create a variable called $CMD. And within that, we're going to store the start process calc. Remember, that's going to start the calculator process for us. But now we want to convert this. We don't want anybody to know what we're trying to do. So what we're going to do is we're going to create a new line. And in this line, what we're going to do is we're going to create a variable. We're going to call it bytes. And then we're going to set it equal. Now, very important here. We have this method here. We have text.encoding. All right. So text.encoding, and then we're going to use two colons, colon, colon, and then we're going to do Unicode. Now, let's stop here. and let's understand what we've done so far. So we just created this new variable here, bytes, and we used text encoding Unicode. So very important. Text encoding Unicode is a class we will use to control how strings are converted into bytes. So we're going to convert this string. This is a string here. We're going to convert that string into bytes. And you're going to see in a second why we need to do that. But let's finish up this particular part of the script. So we're going to say Unicode, and we're going to do a period, and we're going to say get bytes. And then we're going to specify the variable. We're going to say $CMD. It's going to make sense in a second. Just hold on. Right? So what did we just do? We said, hey, convert this right here, and give me the Unicode. Get the bytes of this particular commandlet, startprocess.calc. So we're converting it into bytes. All right. Now, last thing we're going to do is we're going to create one more variable. We're going to say $, and we're going to call this one ENC, and we're going to set it equal to this. We're going to use these brackets, and we're going to say convert, and we're going to use this. You've probably heard of this before. Is we're going to use base 64 string. Now, in order to utilize base 64 is simply an algorithm that is going to encode our commandlet. But in order to use base 64, we have to first convert it into bytes. If we just took this commandlet and then converted it to base 64, we would get a failure. In order to convert this into base 64, we have to first convert it into bytes. That's why we used Unicode get bytes, and we specified CMD. So now that we have converted it into bytes, we can use base 64. Now, base 64, again, like I just said, is a algorithm that is used to encode a command line to make something unreadable. Right now, anybody can read this, start process calc. However, when we use the base 64 string, in a second, you're going to see what we mean when we say it's going to be unreadable. All right. So we're going to now put in the variable bytes, right? Because remember, we stored this command equal to bytes. Now we're going to make it equal to encode, ENC, this variable here. All right. It can be a little confusing, but just work with me here. All right. And then last but not least, we're going to print out whatever that encoded base 64 string is. And we're going to just say $ENC. So now this is a run script button. So once we have confirmed that our script looks good, we've confirmed that everything is correct, we can click this and it's going to run the script. So when we click this, boom, let me zoom in a little so you can see here. So what happens is the script that we just ran, the output is here. So we see ENC, and now we see something here. This is the converted command. This is the encoded command. So we converted it to base 64. And like I said, this is not human readable. So what have we done? We started from start process calc, and we converted it into this encoded command. All right, so let's copy this. And then let's now run the encoded command. All right, so look at this. We're going to type in here PowerShell, and then we're going to say encoded command. We're going to type that in, very important, encoded command. And then we're going to paste in that encoded command that we got from our script. Now let's go ahead and click enter. And boom, calc just executed again. But we did not explicitly type this in. We just used the converted base 64 encoded command. Now, this may seem kind of benign. We're just executing calc. But let's say that instead of this executing calc, this executes a file called maliciousbackdoor.exe, or the script is doing something where it deletes files in the registry and it does some command and control communications, so on and so forth. When our security tool scans or looks at the script, it's going to see that it is encoded, and it is going to be able to evade the security tool because it's encoded. That's why this is a very important concept to understand, the power of utilizing encoded commands. So you need to be able to understand how to encode and then decode this type of activity. So this is just a bonus for us here. I want to show us a website. So there's a website that you should know. It's called CyberChef. All right, this is called CyberChef. And essentially what it does is it converts base64. So what we do is we're going to call it a recipe. So we're going to look here from base64. We're going to now say decode. We're going to ask it to decode it for us. So decode text. And we're going to use this encoding algorithm here. So now let's go back and take our encoded command and let's paste it in here. When we look closely, we see that the output is start process calc, right? So what did we just do? We took that encoded command into CyberChef. We gave it the base64 algorithm that was utilized to encode, and then we told it to decode it back to its original format, which is start process calc. And you're going to use CyberChef a lot in your cybersecurity role because in your day-to-day functionality, you're going to be coming across encoded commands a lot, and you're going to have to know how to decode it. You're going to have to know how to take this encoded command and decode it and see what it's actually doing. Because hackers use this, system administrators also use it as well. So you're going to have to, like I just said, know how to take these encoded commands and then decode it. All right. So those are the PowerShell scripts that we ran. So now what we're going to do is we're going to go back and what we're going to start executing some more activity on our Windows host. And this time we're going to convert back to Jupyter notebooks and see how we can now further use pandas and Python scripts to perform threat analysis. All right. So we'll see you in the next video.